Hello, welcome back to Learn Economia. In this video, we are going to look into the limit and continuity aspect. First of all, just understand what a limit is. So, this is actually defined as a number approached by the function as an independent functions variable approaches a particular value. Okay, so if you are taking the case of an example, just consider a function f of x is equal to 4x. So, in this, the limit of f of x as it approaches 2 is 8. So, you have to understand that this limit to 4x it is written as 4 into 2. Here the value of x is considered as 2, so it's written as 4 into 2. 8 limit x. So this 10 to 2 4x. That means that 4 into 2 is equal to 8, right? So just taking this as an example, you can see that a limit of a function is a number that function reaches as the independent variable of that function reaches a given value. So you'll be given a situation like x tend to or approaches to this particular number. So that particular number would be given. You have to substitute that number to x so that you can find the answer. Okay, the value, just consider the case of a, so to which function f of x gets close arbitrarily as the value of independent variable x becomes close arbitrarily to a given value of a, which is symbolized as f of x is equal to a. So that's just a definition. But if you look into certain points which you have to take into consideration while going for limit, you can see that if limit x tends to a, then f of x is expected to be the value of value of f at given x is equal to a. So just think that given the values of f near x to the left of a, so this is known as left hand limit of f at a, and in the case of right hand limit of x tends to a, you can see that limit x a plus. Earlier in the case, you could see that limit x a minus, because it is left hand limit, and in this case it is right hand limit. Okay, so if the right hand limit and left hand limits coincide, what will happen is that the values of limit x is equal to a, f of a at x is equal to a, and it is denoted by limit x tends to a f of x. Fine, just think of a case where you have to find the value of limit x tends to 3. Here x plus 2, that's a function where you have to substitute the value of 3 uh, in the place of x, so that the answer would be 15, right? Now, just understand the properties of a limit. You can see that the limit of a function is represented as f of x. It reaches L as x tends to a limit a, in such a manner that a limit x tends to a, function of a is equal to L. And the second property is that the limit of sum of two functions equals the sum of their limits. Okay, then third property is that the limit of any constant function is a constant term. If you are taking the constant of a, then the limit of a limit x tends to a c is equal to c itself. Now, the limit of a product of constant and a function is equal to the product of constant, and the limit of the function is such that limit x tends to a m f of x is equal to m limit of x tends to a f of x. Okay, then if you look into the Gaussian rule, you can see that it looks by taking an example of limit x tends to a f of x divided by g of x, and this is the limit x tends to a f of x limit x tends to a f of x divided by limit x tends to a g of x. So this is the case where limit x tends to a g of x is not equal to 0. So that you have to take into consideration, that is very important. And in the case of continuity, I have discussed the case of limit. Just understand what a continuity is. So this is a very important topic in the arena of calculus. We have to we can test for continuity. That is a very important property with respect to continuity. And if you have a function with you have to examine whether that particular function could be used to graph it, or whether you can go for any kind of graphical representation with respect to that function. And after plotting the graph, you can see whether the graph is continuous or whether you are getting any kind of scattered kind of a diagram or a graph. When you are going to pre-calculus as well as calculus, a conceptual definition, it is almost sufficient with respect to continuity. But if you are going for higher levels, actually a technical definition, it is very much required. So in this video, we are going to look into a more technical kind of a definition with respect to both limit as well as continuity, and we could see that both these things are very much related. We have to understand that many functions have the property that they can they can be traced with the help of a graph, and these are considered to be continuous function. If you could graph the function, that means that the function is continuous. A function is considered to be continuous at a particular point if there is no break in the graph. That's very important. If your graph is broken, that means that your function is not at all continuous. If you have breaks in between your graphs, that means that you cannot join the points in the graph. Again, the function given, it is not continuous. A precise definition with respect to continuity is that if you are looking for a real function, and this is provided generally in a calculus introductory course in terms of limits idea. That's why I told you that both these concepts are very much related. So first, a function f with a variable x. This is continuous at a point A on the real line. If the limit of f of x when x approaches the point A, it is equal to the value of f of x at A. So that means that f of A, okay. And so if the function is continuous, that means that you can join every dot in the every points of that particular function. So you can define continuity as by taking into consideration the three conditions which you have to satisfy, and you have to check for every function with respect to these conditions to see whether it is continuous or not. First of all, it is f of a is defined. Then limit x tends to a, f of a exists. Limit x tends to a plus f of x, limit x tends to a minus f of x is equal to f of a. So these are the different conditions which you have to satisfy to make it sure that your function is continuous. A function is actually can be discontinuous as well. As we have told earlier, if there is a gap in between your function, that means that your function is discontinuous. So here you can see a continuous function. As you could see from the figure, the graph is actually continuous. You cannot figure any kind of breaks in between. So you cannot figure out any kind of breaks. That means that your the function given here is continuous. So that's all for today. Please like, share, and subscribe to this channel for more videos, and be a part of my Telegram group and Telegram channel to discuss your doubts. I'll be providing the links of the same in the description box. That's all for today. Thank you.